For this data, we have to understand the pattern and predict for new values. Similarly, 4 can be written in so many ways. In TensorFlow, there are also data sets that are available. So that will be the last step. These are different shades of gray data. There's going to be one input layer, there's going to be one output layer, there's going to be a lot of hidden layers. So we are getting closer to understanding the patterns. In this video, we will be building your first neural network model together. If you're an absolute beginner who has never created models before, this is the perfect place to get started, because the entire point of this video is to realize that how easy it is in terms of code to create and use models because of the libraries and the frameworks that are available these days. So if you know any one programming language, you should be able to follow, because I'm going to write the code and I'll be explaining it line by line as we go through it. So without wasting any time, let's get started. Usually this is the first model that anyone gets started with. We are using one of the most common data sets that are out there. So I hope you are excited. Let's begin. Let me first give you an idea of the goal of the code that we are going to be writing. What are we trying to achieve from our model? In this video, what we are going to be doing is something called supervised learning. It's okay if you do not know this term. Please go and check out the intro to ML video after this video, so that you will have an idea of the different machine learning algorithms that are out there. But for now, let me just give you a quick idea of what happens in supervised learning, so that you can understand the goal of the model that we are going to be creating. For clarity, I have taken a lot of examples over here. Note that for all of these examples, the pattern is that we are given some data, and for this data, we have to understand the pattern and predict for new values what will be the Y value. Let me explain it. See, for house price prediction, we will be given a lot of data that usually for this size of the house, this number of bedrooms, this location, this is the house price. So what our model is supposed to do is go through this data, go through the lot of configurations and see the house price, understand the pattern, so that when a new configuration comes, we'll be able to tell the house price. Similarly, in email spam detection, we have a lot of mails which are marked as spam or not. So we already have the data set where a lot of mails are present and there is a label attached to it whether the mail is a spam or not. So that tomorrow when a new mail comes, we will be able to detect whether the mail is spam or not. Similarly, for employee salary prediction, we have years of experience, designation, location, and similarly more features like this, based on which our model is supposed to understand the relationship that usually for these features, this is the employee salary. So that tomorrow when the new employee comes, we are able to predict the salary for that. So the pattern over here is that always for a lot of features or independent variables, the goal is to understand the relationship with this label. So the data that we have is labeled data, and these are the labels or the dependent variables that we are supposed to calculate. So that tomorrow when new X value comes, we are able to predict the label. Now similarly, let me show you that what is the data set that we are going to be dealing with. These are different examples of supervised learning. What we are going to be doing is also supervised learning. Before we move ahead, I would just like to take a minute over here to tell you how you can learn live with me at Educosys. At Educosys, we have various courses. For interview prep, I have high-level system design, low-level system design, DSA. For project-based learning, if you want to create really interesting, scalable projects, not simple clone ones, check out HHLD. It is MERN plus DevOps plus HLD. We have hands-on generative AI course where I have not just covered the application side, but also the internals of LLMs in a lot of detail with white paper discussions, transformer architecture, and so much more. 10 hands-on projects have been covered over there. Please check out the curriculum, the testimonials, the LinkedIn profiles of all our students is tagged. Plus, if you enroll for any of our courses, you get lifetime access to all the batches, the past batches, the future batches. So you will get access to the Zoom recordings of the live class. So you actually get a feeling that it is live itself. This is the feedback that I have gotten from all our students, that it really feels like it is live only, even if it is not live. But if you want to attend live only, you will get access to all our future batches as well. So at least check it out. I would love to be part of your further learning journey. And if you still have any questions, feel free to reach out to us at support@educosys.com or just drop a WhatsApp or call us at this number. And now let's continue. The data set that we are going to be picking up is called MNIST data set, and I will show it to you. What it has is a lot of images, and every image corresponds to a digit. So there is a label attached to every single image, and the digit is either 0, 1, 2 and so on till 9. So it is a single digit, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have a lot of images, all are of the size 28 by 28 pixels, and there is a label attached to it. So we are going to train our model. So our model will be able to understand that this image means this digit. So that when a new image comes, our model is able to tell that this is the image of this digit. That is the goal of the model that we are going to be creating. The data we are going to be using is in MNIST database, Modified National Institute of Standards and Tech database. This is a very common database that is present in a lot of places. So how it looks like is that there are a lot of 28 pixel by 28 pixel black and white images. So why is it there? Why? What are we trying to achieve? See, you can see that 9 is written in a lot of ways. Some people put this curved line, some people put like a horizontal line over here. Similarly, in 7, you can see some people put this horizontal line in between, right? Sometimes the 7 line becomes very curved. Sometimes it is straight with a very nice angle over there. Sometimes 8 is written like in two circles very properly. Sometimes it might be slanted. Just like 1 might be straight, or sometimes it might be slanted, or it might have this thing and a horizontal line at bottom as well, right? 2 might sometimes be like this, sometimes it might have a circle in between. Similarly, 5 sometimes becomes completely curved, it starts looking like S sometimes, right? Some people write it very properly with a straight line and then a curved. Similarly, 4 can be written in so many ways. Sometimes 3 might end up looking like there's a circle at the bottom, right? So what our model is supposed to do is go through so many different images of each of the digits, so that it is able to identify the pattern that usually if this change is happening, it is still this particular digit. So what we are going to do is we are going to train our model. Basically, we will make our model go through 60,000 images of different digits. See, every image has a label to attach to it, that this image is of this digit, this image is of this digit. So our model will learn that usually for this image, this is the label, this image, this is the label. So after training, when our model sees the new data set, it will be able to understand, oh, this image is this, right? So usually how this data is split is that it has 60,000 training images and 10,000 testing images. So you will find this data set in a lot of places. You will find it in Kaggle, you will find it in TensorFlow. We are going to be using TensorFlow any which way. So for those of you who do not know what is TensorFlow, see, TensorFlow is a framework that is developed by Google. It makes it very easy to build models, to use models, to be able to test models and so on. And on top of TensorFlow, there is something called Keras, which gives API in very easy way. See, you don't need to know so much detail. If you do not know, it's fine. The point is we are going to be using framework TensorFlow Keras, and we are going to be using it to write our code so that it becomes very easy to build our models, to evaluate our model and so on. Right? And in TensorFlow, there are also data sets that are available. So you can see in TensorFlow itself, this data is available. So the 60,000 training images that you can see and 10,000 testing images are present in TensorFlow itself. So when we use this particular library, this framework, we will have the data set available. So here you can see each of the image is of 28 pixel by 28 pixel, and it has a label which is an integer. Label is what? That 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You can see this is how it looks like, that for this image, this is the label. So for 4, 1, 0, you can see, right? So what we are going to do is we are going to load the data set from TensorFlow, and then we will build our model and so on. We are finally ready to get started with the code. Before doing that, let's talk about the different steps for which we are going to write the code. First things first, we obviously have to get started by loading our dataset. Where is our dataset present? It is present in TensorFlow. We are just going to load and see how it looks like. So we just saw, right, that MNIST dataset is present. There is training dataset, there is testing dataset. So once we load it, we will see that, okay, we are able to see our data, everything is ready. And once we have the data, we are ready to deal with our models. So to be able to do anything with the model, we obviously have to create the model. So that is going to be our first step. Because it is going to be our first ever model, I'm going to keep it super simple, and I'm going to explain it in detail, so don't worry about it at all. Once we are done creating the model, before using it, we have to compile the model. And see, things like compiling is actually very easy because we are using libraries. It's literally one line code that we are going to be writing, and you will see that it is so easy to do all of these steps. And after compiling, obviously we are ready to train our model, right? So we are going to train our model. Now for training, what data are we going to use? We are obviously going to use the MNIST data that we just loaded. But see, we went through it, right, that there are going to be 60,000 examples that we are going to use for training and 10,000 for testing. One important point over here, see, testing and training data set should be completely different. Why? See, if we use testing data set during training also, then our model has already seen the data, right? So it is biased. So it is not like a new data when we are testing it. It is already seen the data, right? So when we have to test our model, we should give a completely new data. So this is a very important point. So usually when you have your own data, you can decide your own split. Like if you have 100K data sets, you can divide it according to your choice, like 80-20%, like 80% for training and 20% for testing, maybe 90-10 or 75-25. So that is up to you. Because we are using the data that is present in this TensorFlow itself, in the library itself, we are going to be using the split that is given to us. So it is given that when we load the data set, 60,000 images and their labels we are going to be using for training, and the rest 10,000 we are going to be using for testing. So when we train our model, we are going to train using the 60,000 images and labels that we have when we loaded the data set. And once we have trained our model, we obviously have to see how our model is performing. So we will be doing what? We will be evaluating our model. So that will be the last step, evaluate the model. And we will evaluate using which data set? The testing data that we have when we loaded the data. Yes, we are going to be writing code in Google Colab, so it will be very easy for you as well. Just like all the other videos, the link is going to be in the description, so you can always refer to the code. And before starting with the loading of the dataset, the first thing we obviously have to do is to install our library. So I'm going to just install TensorFlow over here. And after that, we'll be ready to import everything that we are going to be using, and then we will load our dataset. We are going to be using the layers and the models from Keras. So I told you, right, that the API is there in Keras, which makes it very easy for us to be able to write the code. And we are going to be using NumPy to deal with arrays and everything. NumPy stands for numerical Python. If you do not know NumPy, highly recommend to go through this tutorial after watching the video. And other than NumPy, we are going to be using Matplotlib. And again, there's a video on Matplotlib as well. So this is for data visualization. We are going to be creating a lot of graphs to understand our data in a better way. So Matplotlib will be used for that. Let's load our data set, and for that our data is present in TensorFlow. We are going to be using Keras. There are a lot of data sets that are present, and in that we are going to be using the MNIST data set, and we are going to use this load data to be able to load the data. So if we hover over this, we will be able to see everything that is there about this API, and you can see that it returns a tuple of NumPy arrays, xtrain, ytrain, xtest and ytest, right? So this is what we are going to get in return, and everything is present over here. You can see it is a data set of 60,028 by 28 grayscale images of 10 digits. Grayscale meaning black and white. So 10 digits meaning 0 to 9, right? So 10 digits. And test set has 10,000 images and the training data set has 60,000 images. If you go down, you will be able to see the shape of the test of the training data set should be 60,000. So 60,000 images of 28 by 28 pixels. So this will be the shape. So pixel values are going to be from 0 to 255. 0 stands for black, 255 stands for white. We are going to see that it should be like this. Ytrain is our label. So all the labels should be between 0 and 9, right? So it is just an integer value, and we will have 60,000 values corresponding to all of the images. So we have 60,000 images which is there in xtrain. Corresponding to all the 60,000 images, we are going to have 60,000 labels which are going to be present in xtrain. Ytrain, right? Similarly, we are going to have xtest, which is going to be 10,000 images of 28 by 28 pixels. Again, the values are going to be 0 to 255, and ytest are going to be the 10,000 labels that correspond to this xtest, right? So you can see all the shapes. We'll also try printing it. So first, let's try to load our data, and we are going to put it in these variables. I just copied this from the API itself. So let's load the data. So you can see it is getting loaded from this link. So once it is done loading, you can actually see how your data looks like. So you can suppose see xtrain. What is the shape of it? So you can see it is an array and it is all this, right? So let's first check the shape of it. So xtrain ka shape is 60,000 28 28. Why? 60,000 images of 28 by 28 pixels. Similarly, ytrain shape should be what? Now you should be able to tell this, that there are 60,000 labels. So it is just integer value. So 60,000 labels for all of these 60,000 images, right? Similarly, if you want to see xtest, so that is 10,000 images, all of the shape 28 by 28 pixels, right? So X test shape. Similarly, let's see Y test shape. That should be the labels corresponding to X test. So 10,000 images. So there should be 10,000 labels and just integer values from 0 to 9. And if you want to see the values that are there in X train, Y train, X test, Y test, you can do that as well. It is not just you have to see the shape, you can obviously see the values as well. So if you want to see that, let's try printing, say X train, whatever is the first value in X train. Okay, let's try to see that. And you can see it looks like a 5. So it is a 28 by 28 pixel, right? So 28 by 28 array. And if you can see over here, all the values are going to be between 0 and 255. See, if you see over here, it's basically a black background with white somewhere, right? So you can see black background. So most of the values are 0 over here, right? So you can see there are so many zeros. The values that are there between 0 and 255 are gray. So you can see there like this 253 will be like almost white. So the higher the values, the whiter it is going to be. So these are all different shades of gray. You can see 18, 126, 175 and so on. So this is the X train of 0. If you also want to see the Y train of 0, what should be the value? See, X train is the image, Y train is the corresponding integer value. So the label corresponding to this image is 5. Similarly, suppose you wanted to see the first one, you could have seen the first one. So let's try seeing the first value. So it looks like 0. You can see again it is 0 label, right? Similarly, you can see any. So there are like 60,000 of it. You can also see suppose 345. I can also see like 345, right? So it will be all the label corresponding to the values. So you can see there is a 1 over here and the label is also 1. And similarly, we can go through the test values as well. Just how we went through the X train and Y train, we can also check out X test and Y test. So suppose X test of 10. This is again going to be an image 28 by 28 pixel. It looks like a 0, right? So if I ask you what should be the Y test value of 10, it should be an integer value, an integer label that is 0, right? So here you can see there is a 0. Here you can see there is a 0. So this is how you can go through the content. See, in X train you could see a small images over here, but if you want to plot it, you can also use matplotlib for that. So just to show you, you can do something called plot imshow, and you can just give say X test of 10. And if I plot it, you will be able to see a colored image, but it is in reality a black and white image, right? A grayscale image. So if you want to do that, you can give CMap equal to gray. And if you do that, now you will be able to see that there are 0 values over here. These are all like this must have been 253 and so on. This would have been like 18, like more of black shades, and this is like more whiter like those, right? So these are different shades of gray that are there. In order to be able to create a model, you should have a rough idea of how neural networks look like. If you are someone who have no idea about neural networks, I would highly recommend you to go through this video where I am explaining my father how neural networks work, and obviously I am explaining my father who is 65 plus years old, so anyone can understand this video. It is very, very simple to understand. Plus I'll be creating a lot more different examples and explanations as well, so it will be clearer. The point is that you must have seen these diagrams. These are the most common neural network diagrams that you must have seen. We are going to create a very, very simple version of this. The neural network model that we are going to be creating is very simple. See, these things are called layers. So in any neural network, there is always an input layer, there is an output layer, and then you must have seen that there are a lot of hidden layers, and these neurons are connected to each other, right? So this is the complex diagram that we just saw. This is how neural networks look like. Because we are creating a very simple model, we are going to just have one hidden layer right now, okay? So just repeating that, we are going to have one input layer. What is going to be sent as input to our model? We are going to send our image, right? X is going to be sent. So when image is sent, every image is 28 by 28 pixels. But because we are dealing with like 1D array, we are just going to flatten this 2D 28 by 28 array, and we are going to flatten it to 1D array. So it will become 784 neurons in the input layer. Just repeating that, see, we cannot have 2D arrays in input layer, we have to have a 1D array. So just going to convert the 2D image to a 1D array. So it's like every row is going to be attached. So like first row, second row, third row, fourth row and so on. 28 rows put together, we are going to have 1D array. If you have seen the NumPy video, I have also covered how usually this flattening works internally. But we will just tell that this is how the input layer looks like and it is going to flatten it by itself. We are going to use a flatten layer. Now in output layer, how many neurons are going to be there? See, one neuron is going to be there corresponding to every output that is possible. So what are the number of outputs that are possible? 10 outputs. So the digits are 0, 1, 2, 3 and so on till 9. So there are 10 outputs possible. So there are 10 neurons in the output layer. See, if you do not know the details of this, it is okay. I am just giving you a rough idea that how many neurons are usually there in the input and the output layer. Because we have 10 output possibilities, we have 10 neurons in the output layer, and every neuron is going to give you an output which is going to be probability of that whatever the image was sent over here, what is the probability that this image is 0, what is the probability that this image is 1, what is the probability that that image is 2, and so on. And sum of all the probabilities is going to be 1. So what is going to be your answer corresponding to the input? Whichever digit has the maximum probability is going to be the answer. See, there's a lot of theory involved in the backend, right? But when you write code, you will see that how easy it is. But I highly recommend you should have an understanding of the theory. So when you create models, you will be able to create better models and you will obviously have much better understanding, right? But in terms of code, it is very easy. So a lot of it I am skipping, but like giving you a rough idea also. Now, because it is a simple model, we are using one hidden layer. Now, how many neurons should be there in this hidden layer? See, the number of hidden layers, the number of neurons in every hidden layer is something called hyperparameter. It is something that everyone learns by trial and error. It is not like you should have these many hidden layers or you should have these many neurons, and that is when you will have a perfect model. So there's a lot of unpredictability involved over here. There's a lot of trial and error involved by which we understand that, oh, in this model, if we put these many neurons, it is going to work better. But generally how neural networks look like is there's going to be one input layer, there's going to be one output layer, there's going to be a lot of hidden layers, and in deep neural networks you will see more hidden layers, right? That is why the name deep neural networks. This is a simple neural network that we are making, so one hidden layer, right? And you will see the term dense used a lot. Dense meaning each neuron is connected to every other neuron. So every neuron connected to every other neuron. So it's going to look something like this. It's going to look very hotspot. That is why I have not made these lines. So these are the connections from input layer to the hidden layer to the output layer. These layers are called in sequence. Like when we send the image to the input layer, then it is like some calculations happen and then you go to the hidden layer, some calculations happen and then you go to the output layer. So these layers are basically like called or executed in sequence, one after the other. So it's like a sequential model that we are creating. Now that we are done with our first step, loading dataset, we are ready to write the code for creating the model, right? Again, if you do not know the details, I highly recommend you to go through the details, but in terms of code, it is going to be very simple. We are creating a model and we are going to be using something called models that was present in Keras, right? So we imported it and we are going to be using this. And in models, there are different kinds of models. We are going to be creating a sequential model as we just discussed, and we have to mention the different layers that are going to be there, right? So we have three layers. There is input layer. In the input layer, we are flattening our 2D array to a 1D array, right? In very simple terms. So our input shape, we have to mention that what will be the shape of the input that we have to flatten, and that is going to be 28 by 28, right? So this is the first layer, the input layer. After that, we are going to add one hidden layer, and in hidden layer, we are deciding to have 128 neurons. Again, you can decide to have 256 neurons, 200 neurons, 100 neurons. You can also try it, like when you write the code yourself, try different number of neurons and you tell me how the change is happening in the evaluation of the model. Is your model performing better? Is your model performing worse? Like that, right? Then you can see there is something called activation that you have to pass. In the hidden layers, usually the activation function that is used is ReLU, that helps in understanding the pattern of your image. So we are also going to be using ReLU. And in the output layer, so this was your input layer, this was your hidden layer, and now it is turn for your output layer. Dense means that we are fully connecting our layers, okay? So in the output layer, again, we are fully connecting, and the number of neurons is what? 10 neurons, one for every digit. Now in the activation function, because we want probabilities and the total sum of the probability is going to be 1, the one that is usually used is softmax. If you do not know details of this, the more models you will see, the more you will understand. See, this activation functions depends on the kind of problems that you're dealing with, like is it regression problem, is it classification problem, and so on. So for that you should know the different ML models that are there and the details of that. So I recommend this video over there. Okay. Slowly when you go through more and more models, you will be able to understand that for what kind of models, what are the activation functions that are usually used. Now let's create our model. It's taking some time. And we are done creating the model. Now we are ready to compile our model. Before compiling, it is giving us a warning that we can just remove the input shape. So let's do that and let's run it again. So we have created our model and now we are ready to compile it. Now to compile the model, it is actually very easy in terms of code. All we have to do is model.compile, and actually we have to give some configurations over here. See, for these configurations, if you have a clear understanding of the theory of neural networks, you will be able to do it better. If you don't, it is fine, because with time, as you deal with more and more models, with time, if you see more and more neural networks, you will understand, right? It is also giving autocomplete. So let's put that. It has given for fit and evaluate. Let's remove that. See, in autocomplete, it gives sparse categorical cross entropy as the loss function, which is the configurations that we have to do while compiling. Why this? Because usually this is the loss function that is used for problems that are multi-class classification. Now you're thinking, what is this? Making it very simple, see, the problem that we are dealing with is a multi-class classification problem. Why? Because we are classifying our images to one of the 10 classes. What are the classes? That is this image 0, is this image 1, is this image 2. So these 10 digits are like 10 classes. So every image that is there, we are classifying it into one of the 10 classes. So usually when it is a multi-class classification problem, this is the loss function that is used. Again, I am telling you, as you see more and more neural networks, these things will become clearer, and you should also go through the theory. But in this video, again, the focus is to show you that in terms of code, it is so simple, because all we have to do is give some configurations over here and we are done compiling our model. We are finally ready to train our model. In order to train our model, all we have to do is model.fit. So what we are trying to do is that we are trying to fit our data set into a particular pattern. And here you can see it is already telling what we have to pass. We usually pass X train, Y train, and number of epochs. Epochs is what? Epochs is that whatever our training data set is, how many times are we passing through the model and trying to understand the pattern. And more the number of times we pass, the better it is going to become until a particular point, but not going into that many details. So epochs is that how many times are we passing our entire data set through our model. So we are going to be training our model. So you will be able to see that there are going to be 5 epochs. So this is the first time our model is seeing our training data set, and you can see the accuracy and the loss. Why are we seeing accuracy over here? Because in the metrics we gave that we want to see the accuracy. And loss will be like, how will the loss function be calculated? Using what the configuration we gave, right? But with every epoch, every time our model is seeing the data again and again, the accuracy should become better, the loss should become lesser. So we are getting closer to understanding the pattern between X train and Y train, right? So you can see the accuracy is increasing over here from 82% to 93%. Loss is reducing drastically. You can see we have gone from 0.29 to 0.24. So this is the last epoch, and you can see the accuracy has already become like 94% and so on. There are a lot of ways how we can increase the accuracy as well. But for now, this is good enough. 94% is decent accuracy, right? So this is the training of the model is now done. Now we are ready to evaluate our model and see how it is performing. In order to evaluate the model, it is again very simple. We can do something called model.evaluate. And when we do this, again, we have to pass X test and Y test. Like during the fitting, we will pass X train, Y train, right? During evaluation, we'll pass X test and Y test. And what will be returned from over here? We will get test loss and test accuracy. And let's just run this. So we are evaluating our model on the test data set now. So you can see that test accuracy is 93%, which is almost nearby to the training accuracy, right? So a very important concept is that the accuracy and the loss should be similar for the training data set and the testing data set. If the difference is more, maybe you have overfit the model or underfit the model, which are like different concepts, and we can go through that in a different video. Let me know in the comments how many of you would like to know these details, that what is a overfitting, what is underfitting, what are these different configurations for what kind of models, what configurations are usually given, right? If you would be interested in those informations, let me know. I would love to explain those things as well, right? So we just evaluated and it is performing decent, but this is simple like a percentage that we got, right? Can we see some predictions that our model is performing on the test data set? So we use the training data set to train our model. Now on the test data set, is our model able to make correct predictions or not? Let's see that. In order to check the predictions, all we have to do is model.predict, and here again we can pass our X test, right? So we are asking our model to predict on this test data set that we have, and we are going to find the Y values that are corresponding to this X test, right? So once we predict it, let me just save the result in something called predictions, and let's run it. And now let's also check how does this predictions look like, right? So let's check the shape of it. So when you see that for the 10,000 test data that we had for X, there are 10 values. Why 10 values? See, in the output layer, there are 10 neurons, right? So this is like output of the neurons for the 10,000 inputs, right? So if you want to see, suppose, predictions of 1. So you will be able to see that there are 10 values over here. Each value is what? It is a probability that, what is the probability that whatever was the input, what is the output correspond, what is the probability that it is 0, it is 1, it is 2. So what is the probability it is 0? This is 10 power something minus 21, this is 10 power minus 4, 10 power minus 1, 10 power minus 12, 10 power minus 24, 10 power minus 10, and so on. So what is the maximum value out of this? Seeing it, I can see this is like 99% probability. So this number would have been 0, 1, 2. It should have been 2. If you do not believe me, I am just seeing it manually, right? But you can also print it like this. Suppose I am using NumPy over here to calculate the maximum of these probabilities, right? So if I do that, okay, I am sorry, there is to be one more this. So we can see it is 2. So 2 has the maximum probability, and if you still don't believe me why it is that, let's try to print X test of 1, because we are printing predictions of 1, right? So X test of 1 is 2, you can see, right? Similarly, Y test of 1, if you try to print, it is going to be 2. Similarly, suppose you wanted to see predictions of 10, right? And if you print it, see, the maximum probability is for this one. You can see 99% probability, right? So if you print X test of 10, you can see that it was 0. That is why this got maximum probability. So our model is performing really well. So you can see all the values are correct. This brings us to the end of the video. But guys, I highly recommend that you try writing the code yourself and ask any questions or doubts that you have. I would love to answer them in the comments. And please remember that neural networks is like the basics of deep learning. It is basics. It is very important. If you understand neural networks, you will eventually be able to understand how ChatGPT works internally. It is the basics that you should definitely know. And if you would like me to cover theory about neural networks in more detail, and if you would like me to cover code of more different kinds of models, like this was a classification problem, we can do probably more regression problems and different kinds of data sets, that would be awesome, right? I would love to create more and more tutorial videos. But I think that I do deserve a subscribe and a like and a share for the kind of effort that I am putting. If you like the video, please consider sharing it on LinkedIn or Insta. Please tag me. I really think I deserve 1,000,000 subscribers. What do you guys think? Let me know. And if you have any feedback or anything at all, please do let me know. I would love to incorporate that, and I would love to create more and more videos. Happy learning, guys. If you have any questions, let me know. I'm here to help you. Bye. See you next time.